Hi, welcome to another video on my Raspberry Pi 1 and 2 and LED play, which in my case means that the LEDs controlled by the Raspberry Pi 1 and the LEDs controlled by the Raspberry Pi 2 are supposed to influence each other. In the last episode it clearly turned out that the setup that I had in mind will not work, simply because I can't possibly start them at exactly the same time. So what I am going to do is that, let me scroll down, that I will try to get them waiting for each other. And looking here at Raspberry Pi 1, this means that I will implement something that goes like wait until it really is 1. So I can do that with a while, and or better, while not GPIO. So while this input is 0, do nothing, or say just say print it, and then say while it is 1, do what I intend to do. And this gives me the opportunity, however, I see here something, yes, it is the same color, and this should work from the RPi1 side. So then from this side it waits until it gets a signal from this side. Will this work? I don't know. But I can at least try. So let's just do that, and in this case I'll be able to just start the algorithm on this side, and to my surprise, guess what happens? Here it starts saying that the input is 1. How can that be? Let me just put this into action. What happens here? It's all 0. And here I get 1, 0, 1. And what do I look here? What do I see here? Let me where's the first LED? there. And right now the LEDs function at exactly the same moment. Although this LED isn't quite visible, maybe this will solve it. No, but it is burning. And here you see it is exchanging ones and twos, so let me interrupt this and then interrupt this as well. Ah, that's a nice one. Last time it just went on and on again. Ah, it needs time. So let me here say exactly the opposite. Because here it works the other way around. And that is something I have to take care of, because here I say if this condition is 1, then do this, and if I am waiting for it, then I'll have to completely do the opposite. And let's figure that one out, because maybe the while loop isn't that handy to come in this place. Here's a while not, and here's a while, but here there's an if not. So I do it different. Okay, this one out, and here I put a while not. Let's see how this works out. Maybe better, maybe worse. Now the LEDs are not blinking at the same moment. Now it's one after each other. This one and this one, this one and this one, and here in front this one and this one. So that's a little change. And let's see what happens when I adjust the other ones. So let's turn these ones into whiles as well. that is one thing. Now it is quite handy to check if this will work. There you go, and there you go. And now everything stays 1. Everything stays 0. So let me cut this out. This goes just on. Here there are a lot of zeros as well. And but this is 16 and 31, etc. So the question is, why does it respond like that? And here it suddenly is completely different. What I can do is put the same thing here. And say while and here the same thing. See what happens. Compiling. Shouldn't be too picky. There you go. Ouch. It keeps waiting. What happens here? It doesn't keep waiting. It is 1 1 1. Oh, that is interesting. Now this is interesting. This is all 1, and this isn't running at all. This needs some investigation. And this is quite remarkable. On the C++ side, RPi2 side, it takes a while to stop. So the question is, what is happening here? And indeed, this LED is still burning. And while waiting for this part to stop, we can muse something about this, because now we have whiles on one and the same on both sides, and I do wonder if that is quite handy. So if I take them away and put them to ifs, or more appropriate probably put them all back to comment it out. Oops, not that one. I will have to wait. And the remarkable thing is as well, as you may have noticed in the previous videos and so in this one, that Ctrl-C in the C++ version at times takes a while to stop or to act appropriately. Which can take quite a while even. Why is it happening? I have no idea. It simply is happening. And until then I can't do much, if anything at all. But the point was, of course, this is the only thing happening during the while. Why is this happening? I remember from some time ago that it took over 2 hours to actually stop it. And to continue recording a video for over 2 hours just waiting for this? So why this is happening, I have no clue. What I can do is simply say, okay, which one is it? We're talking about 26187. So 26187. Will this do? This do, yeah. Not a very appropriate way, but it helps. So with the change back, let me recompile. Let me start the Python first. C++ next. This works, but what happens here? Again, starting off with 3 ones and then zeros. What happens here? Nothing much actually, all zeros. What happens here? They're all zeros. So there is now absolutely, this one is absolutely dependent on the C++ side. Nothing happens. So the curious thing is though that they are wired as such that they do influence each other, and they are all zero here. So this is not a very good idea. Let me take a little look back. 3 1 starting, then 0. And also noticeable, this is all input 11. Here we go, input 16, input 31, and here again input 11. But this, oops, three times 1 and 4 times 5 times 0. So what does it here? And here it does all ones. Here 3 times 1 and again 5 times 0. So this makes me wonder why that happens. Okay, I've taken all the conditions out of here again. Let me recompile just for being sure. Ooh, that make wait. Let me save it one more time. Compile it one more time, because now I'm really sure that this is the code that is being compiled. Run this, run that. Starting off with 2 1s and a 0 and a 0. And it is again only the RPi2 side that is doing anything at all. And here nothing at all again. So that is not what I expect it to happen. And then I realize that there is something I should take care of. The point is that with the while, as well as with the if, by the way, you check in this case on one condition, while there are other conditions as well. So what I should actually do is, while this is consecutive, or not consecutive, sequential, I should make this like this. So it takes only one condition really. And I wonder what that gives. So let's just figure out how this works out. 2 ones and all zeros, as well as this. Okay. So let's continue this one. In the same way. So I'm curious how this will work out. Starting. Okay, let's see for the LEDs what is happening. These are both working. The second of both is working and the third of both is working. So that at least is an improvement. But I do think as well that influencing goes one way and not the other, as I originally intended to do. And here you see the ones and zeros are actually going on. Here everything is 0. The question is that a bad thing? I'm not quite sure about the answer. But what I do know is that they look like burning at the same time. Almost the same time, that is. If you look very closely, you'll see that this one, that the RPi2 side first burns, and a fraction of a second later the RPi1 side burns. So that may actually look like it is sequential and one influences the other. Let me see if I can get a clear image of that. Yeah, this one burning is hardly noticeable. This one is better noticeable, but thanks to those jump wires there's occlusion of some LEDs. Anyway, I think this is a much better solution, and on this RPi2 side I think I should leave it like that. Is this LED play as I intended? Not quite, because I recall that I want from this to this one and from this to this one, and I doubt that that is exactly going to happen. For now, giving the problems that I had with the chronological or synchronical starting of the scripts, that won't be the original thought, that is. So I think I'll end this LED play experiment and come up with another nice idea. So for now, thank you for watching, and I'll be back with another kind of experiment.